In this video, I'll be talking about the components of a hydronic heating system and their purpose. In this video, I'm just showing the layout of the hydronic heating system in our shop. A hydronic heating system is a system that uses water that is either cooled or is steamed, and then the water will be distributed in the system to be able to give either warm or cool air to the spaces that need it. Hydronic heating systems are very efficient and have lots of benefits. The temperature levels are more consistent, the heat transfer is better. You do not need as much space as you would need if you were using a system that involves ductwork. There is less liquids and other moisture that is taken away from the air indoors, and there is no debris that goes into the conditioned space. The components of a hydronic heating system are a boiler, circulating pumps, expansion tanks, valves, terminal units, and air removal components. A boiler is a closed container using a hydronic heating system to heat the water in order for it to flow through the hydronic system. Fuel is usually burned in order for the boiler to heat the water. Conventional boilers are a type of boiler that function at temperatures higher than 140 degrees, and this is good because it makes sure combustion gases do not condense. There are also condensing boilers designed to condense the combustion gases inside of the system. These types of boilers have heat exchangers in them that help with the removal of extra heat that comes from the combustion gases. This is a picture of a boiler or a water heater. Now let's move on to circulating pumps. A circulating pump controls the flow of water through the piping of the hydronic system and is just a motor-driving pump. A circulating pump is pretty straightforward, and most systems have it in order to have a good flow of heated water through the pipes. Expansion tanks are a two-sided tank. One side of the tank is filled with water, which is the water that provides the hydronic system with the water it uses to cool or heat the occupied space, and the other side is filled with air. The two sides are either separated by a rubber diaphragm or a rubber bladder. Systems with rubber diaphragms and rubber bladders usually are also installed with air fittings that are used to control the amount of pressure in the system. The older expansion tanks have combination valves, and these can be helpful because they not only allow for the water to be drained out of the tank, but also allow the required air to come into the tank at the same time. There are a few different types of valves used to make sure that the hydronic heating systems run efficiently. The valves are needed to control the flow of water through the system. There are mixing valves, which take hot water in one way and have cool water coming in the other way. This helps get the temperature needed for the system. Mixing valves can also be used to control how hot or cold the temperature is in the hydronic system. There are also balancing valves, which make sure the hot water or cold water gets evenly distributed to the terminals in the system. Pressure-reducing valves are also installed in hydronic systems to reduce the pressure amount of water that gets supplied into the water main. This is important because you don't want water coming out at too high of a pressure. There are also flow control valves and backflow preventers. Flow control valves are used to make sure water is going in the right direction, and backflow preventers make sure that the water does not go the opposite direction and does not let water go back into the water main. Terminal units are heat exchangers that allow for the movement of heat from the circulating water in the hydronic system to the air in the conditioned space. Terminal units are also known as the heat emitters and can also transfer this heat through a combination of both conduction and radiation. There can be multiple types of terminal units in the system, and there can be up to 4. Air removal components are a must for the hydronic system because if the proper air is not removed out of the system, and then the system will not only be loud, but the water will not be able to flow the same. There is different types of air in the hydronic systems that get removed by the air removal components. There are free air, which is the air at high points in the system, dissolved air, which is the air that gets trapped when the water is in the process of circulating, and entrained air, which is the small air bubbles. Here are a few pictures of the layouts of a hydronic heating systems.